This question asks for the one or two word phrase that best describes the shape of nitrite, NO2- ion. Here, we're essentially looking for the molecular geometry. In order to find the molecular geometry, we must first find the Lewis structure. To find the Lewis structure, we have to start by counting the valence electrons. So, in this case, we have 5 plus 2 times 6 plus 1 extra, because it's negative, for a total of 18 electrons. Least electronegative atom in the middle, which is nitrogen. So we put nitrogen in the middle. We bond it to 2 oxygens, like so. And I'm going to go ahead and fill the octets of both of the oxygen atoms here, like so, because that gives me an octet around each, which is 2 times 8, which is 16 electrons. That means I have 2 more electrons, and nitrogen doesn't have an octet, so therefore it's going to be like that. Now I've used all 18 electrons. I put the 2 extra on nitrogen again because I had used 16 when I filled the octets of oxygen. Nitrogen still didn't have an octet. Since I don't have enough electrons to fill the octet of nitrogen, I'm going to consider a multiple bond. And in this case, because of resonance, it doesn't matter if I pick this or this. I'm just going to go ahead and pick this one and move that into a double bond. Notice that I fixed the Lewis structure. I didn't attempt to start over. So I'm just rewriting like so. So I moved these into a double bond. I went from 3 lone pairs on oxygen to 2 lone pairs on oxygen, and instead of a single bond, I now use those 2 electrons to make a double bond. Now, I want to minimize or at least check my formal charges. These 2 oxygens are different. So in this case, count the dots as 1, count the dashes as 1. Oxygen wants to have 6 electrons around it. We consider 1 of the 2 electrons in the bond to belong to nitrogen, 1 of the 2 electrons in the bond to belong to oxygen. So essentially we count the bond as 1 electron for oxygen and 1 electron for nitrogen. But as we count oxygen, it wants 6 electrons around it and has 1, 2, 3, 4, 5, 6. It's happy. Nitrogen wants 5 electrons around it and has 1, 2, 3, 4, 5. It's happy. This oxygen wants 6 electrons around it and has 1, 2, 3, 4, 5, 6, 7, making it negatively charged. We could have expected a negative charge because the sum of the formal charges equals the charge on the species, and this is negatively charged. We could have also expected that that negative charge would be on oxygen because it's the outside atom or the more electronegative atom. So this is a good Lewis structure of NO2-. Note that because of resonance, I could have put the negative charge here and the double bond here. The extra lone pair would have to be here to move the negative charge. Finally, we want to describe the shape of this thing. To describe the shape, we want to count 2 things. The total number of domains and the lone pairs. So this is for the electron geometry. We want to, for the molecular geometry, we want to look at the central atom only. So we have 1, 2, 3 domains. So the number of domains is 3. This oxygen, this lone pair, and this oxygen. The number of lone pairs is 1. So we have 3 domains, this oxygen, this lone pair, and this oxygen, and 1 lone pair. Here's the lone pair. Note that we only find the electron and molecular geometries for the central atom. So here we have the central atom nitrogen. Now this is a table that I found on Wikipedia. So if we go to steric number, which is the number of domains, 3, this is 3 with no lone pairs. So this is 3 with no lone pairs. This is 3 with 1 lone pair. And they have here V shape. I've often heard this as bent, so I'm going to go ahead and change that to bent. So I want to put as my shape here for NO2 as bent. So sometimes the things from Wikipedia aren't the best or exactly the same as in the textbook. I've heard 3-1 called bent before.